going to bring these snow and that snow folks that live in thunderstorms with that.
Hi again, everyone. I'm meteorologist Leslie Hudson reporting from Cocoa Beach, Florida, as we continue our special hurricane series, The Mean Season. Today on day 3, we're going to take a look at the science behind tracking the storms, including cutting-edge technology with satellite imagery, how much salt in the ocean can play a major role in hurricanes, and also we're going to take a look at what scientists are trying to discover to stay one step ahead of the storms. Even though it's 2019, hurricane forecasting is not an exact science. Unfortunately, each year people die indirectly or directly from hurricanes and cost the U.S. billions of dollars in damage. So the hunt is on from weather scientists to find better forecasts and more accurate ways to stay ahead of the storms. From 22,000 miles up in space, tropical cyclones like Alberto seen here are impressive, determined, powerful. 2 years ago, the GOES-R, now known as GO-16, became operational, and it truly revolutionized weather forecasting, but in particular, tropical forecasting. Satellite imagery is sent back to Earth more often with super clear resolution. The GO-16's Geostationary Lightning Mapper, or GLM, is the first operational lightning mapper that has ever flown in orbit. It's a crucial part of tracking thunderstorms early on, before they become more powerful organized storms or hurricanes. Another way to keep ahead of the storms? Last season, NOAA and the U.S. Navy launched the most unmanned ocean gliders ever used to offer support for the Atlantic hurricane season. These ocean gliders gathered more than 40,000 temperature and salinity profiles that were fed into hurricane forecast models. The glider data, as well as data from other ocean observing systems, show that if there's lower concentrations of salt in the seawater's surface, it can be a clue that this lighter water may form a warm cap that can prevent cooler water from welling up to the surface. This warm cap then can fuel a hurricane's strength, making it stronger. Glider data also helps scientists better predict if the cooler water lying just below the warm surface waters is likely to rise and mix at the surface. If it does, the cooler water will likely weaken a hurricane's strength. Scientists say that warmer oceans and warmer air temperatures are making hurricanes more deadly, in part because warmer air can hold more water, and that makes the hurricanes stronger. Multi-decadal patterns that run in 25 to 40-year cycles affect ocean temperatures, and that too can impact hurricane forecasts from year to year. Forecasters say the Atlantic has experienced warmer sea surface temperatures since 1995, and as a result, the region has been experiencing a high activity era. This era is known as the Atlantic Multi-Decadal Oscillation, or AMO. The AMO is a climatological cycle that affects the sea surface temperature of the North Atlantic Ocean based over these long-term temperature trends.
This is a pattern that lasts anywhere from 25 to 40 years historically. And that pattern, since 1995, has been associated with warmer Atlantic temperatures, stronger West African monsoon, which has really been giving us the increased activity since 1995. There's no indication that we're out of this high activity era.
Scientists are looking at these long-term trends like the AMO, as well as their upgraded radar and satellite technology to keep all of us ahead of the storms. Coming up on day 4 of our hurricane series, The Mean Season, we're going to take a look at the National Hurricane Center's storm predictions for this year and what they look at each and every season to try and get a success rate better than 70%. For now, I'm meteorologist Leslie Hudson reporting from Cocoa Beach, Florida for MyRadar.